Today we're going to be working on lesson 3.3. Before we get started, let's recall what happened in chapter 2. What is the converse? The converse meant to switch the hypothesis and conclusion. If the conditional statement was true, did the converse always have to be true? No, it didn't. Let's think about it. If the measure of an angle is 34, then the angle is acute. The converse of that is, if the angle is acute, then the measure of the angle is 34. And that would not be a true statement. Today we're going to be working with converses. If corresponding angles are congruent, then the lines are parallel. So today our postulates and theorems are going to be proving lines parallel. So if 2 and 6 are congruent, then L and M are parallel. So for example, which lines are parallel if 1 and 2 are congruent? Hint, which line is the transversal for angles 1 and 2? So if I look at angle 1 and angle 2, the lines that are being used are line A, line B, and it looks like M is the transversal. So the lines that would be being parallel are A would be parallel to B, and the reasoning would be the corresponding angles converse. Whereas in lesson 3.2 we said corresponding angles postulate. Today when we're proving lines parallel, we're using the converse. Here's the converse of the alternate interior angles theorem. If AIA are congruent, then the lines are parallel. Alternate exterior angles converse. If alternate exterior angles are congruent, then the lines are parallel. Same side interior, if they are supplementary, then the lines are parallel. So just like we did in 3.2, except now we're proving lines parallel. So looking at these, it says which lines or segments are parallel. Justify your answer. So what I'm going to do is look to see which lines are being used. D, E, T would end up being the transversal. So in number 1, we're proving D parallel to E, and those are corresponding angles. So we're using the corresponding angles converse. Number 2, I see a transversal, line, line. Looks like these are alternate interior angles. So we're going to be using the AIA converse. And I need to erase so I can see the names of my lines. So it looked like this line and this line were going to be parallel. So AB parallel to DC, using correct notation. Number 3, the transversal we're using is here, and then it looks like the lines that would be parallel are there. So RP parallel to SQ, and those could have arrowheads or not, and that's because of alternate exterior angles converse. So just like we did in 3.2. So why don't you try these 3. Please pause the video while the students work. Here are the answers to 4, 5, and 6. Corresponding angles converse, alternate exterior angles converse, and corresponding angles converse again. Developing proof. Complete the flow proof below. This is like a 2-column proof, except that it's called a flow proof, where you start with an idea on the left and then we just build and move to our final step. So looking at the given, x is parallel to y, happens right here, and then it's also given that 1 and 2 are supplementary. And I see that right here. So maybe underneath this we should say given. And then both of our given statements are taken care of. So if we look at our picture, if x and y are parallel, we're going to use the same side interior angles are supplementary. So for us, we would say same side interior angles. So if the lines are parallel, then same side interior angles are supplementary. So we're going to say the measure of angle 2 plus measure of angle 3 equals 180. And actually, I think I should actually use those words instead, excuse me. So, angle 2 so we would say angle 2 and angle 3 are supplementary. Then what we have is that 2 and 3 are supplementary, 1 and 2 are supplementary. So it looks like 3 and 1 are both supplementary to the same angle, then they are congruent. And our reasoning for that would be the congruent supplements theorem. Then it looks like we're going to use transitive property. So if 1 is congruent to 3 and 3 is congruent to 4, we can say 1 is congruent to 4. Going back to our picture, if 1 and 4 are congruent, then we have corresponding angles, and by the corresponding angles converse, if they are congruent, then those lines are parallel. We will save this proof for when I get back. Numbers 9 and 10. Determine the value for x which will make the lines parallel. And here comes the algebra. So looking at the angles, I see alternate exterior, and they are equal. So 2x plus 6 would have to equal 42 for our lines to be parallel. So we get 2x equals 36, so x would have to be 18. So then, if we plug in, that would give us 42 degrees. Number 10, determine the value of x. So these are same side interior, so they would have to be supplementary. So our equation, 98 plus 3x minus 17, would have to be 180. And we could figure out those calculations very quickly. So try numbers 11 and 12. Please pause the video while the students work, and the answers will be ready for you in a minute. Here are the answers. This concludes my video for today.